Welcome to Permissible Values for Radical Expressions. So we're going to take a look at, instead of the non-permissible values as we did in the last unit, we're going to look at permissible values. So when we're dealing with the real number system, so that's rational numbers as well as irrational numbers, we know that we cannot take the square root of a negative number. You can try that on your calculator. But you will not be successful. So let's try square root of negative 64, and there's your math error, right? So we must be careful when we're dealing with equations, which we're coming up to. So we're just going to take a look at this. So the square root function only works for numbers that are greater than 0. And so what that means is that we need to make sure that we have a positive number under here before we take the square root, right? So what are three values that we can put for x, right? That's an expression, so x can be anything, and it doesn't matter if you give me perfect squares or not, it just doesn't really matter, right? So for example, 1. Square root of 1 totally works, right? What else? Well, we can go with the perfect squares, and we can go 4, 9, or we could go 2, 3, right? It doesn't really matter. What values could we not substitute in place of x? Well, anything negative. So how do we state the permissible values? Well, we know that whatever is underneath the radical symbol must be greater than or equal to 0. So when we have a monomial that has a variable, it depends on what kind of exponent we're dealing with. So if the exponent is even, then there will be no restrictions. And that's because we can take a negative number, square it, and end up with a positive number, and therefore take the square root, right? No restrictions. If the exponent in the variable is odd, there will be a restriction, and usually that is x is greater than or equal to 0. So we'll look at the permissible values here. So here we just have to make sure that x is greater than or equal to 0. And here there are no restrictions, so x is an element of real numbers. When we are dealing with a binomial, we have to make sure that the entire expression that's under the radical symbol cannot be negative. So what we'll do here is we'll write an inequality where the expression is greater than 0. So we have to make sure that this is greater than or equal to 0. And it makes sense because we know that we can't stick a negative number in there. So we'll solve simple linear equation, and we just have to make sure that we end up with a number that's greater than or equal to 3, right? So this time we write this greater than 0. Continuing on. 4 plus 7x negative 4, divide both sides. And we've dealt with those already. And the last one, greater than or equal to, we'll isolate x. And way back in grade 9, we learned that when we divide or multiply both sides of an inequality by a negative number, we need to reverse the inequality symbol. So that's kind of a little remember right there. Remember to reverse the inequality symbol. And that's it.